Today I'm going to be talking about my master thesis project, that it's privacy-preserving machine learning for collaborative data sharing via Auto-encoder Latent space embedding. My partners and advisors were Jesus, Hernan, David, Alejandro, and Carlos. So, first of all, why do we care about collaborating data sharing between organizations, but more specifically, why do we care for developing collaborative machine learning models? So to put this into words and an example, imagine there are two organizations. They both have access to some users' data. For example, they share a common user population, but they both have different information. So, for example, one of them have financial information, like a bank, for example, and the other one have grocery behavior, grocery patterns about users. And they both want to create a shared model that predicts some kind of metric, such as credit risk. And this example is really important because that was what was actually happened in the previous organization I was working for. We were two different organizations that would like to develop a novel risk metric from user, and particularly for non-bank users. So the grocery pattern was really important. But due to privacy policies, some of the information couldn't, some of the organizations couldn't share this information. And because of this, the model could not be deployed and could not be developed at some point. But as you may know, they both have different aspects of the user, so it's really important for them to share this information. So the question here is, how do we share this information without actually sharing this information? And to solve these questions, as you may know, there's a really cool area of study that is called privacy-preserving machine learning. However, we would like to do specifically data-oriented privacy-preserving machine learning that is actually perturbating the data, changing it a little bit, but keeping the patterns of the information and from the user and observations. So how do we do this in a smart way that keeps the observations patterns and that keep joining users that are alike? In this way, we thought about a latent space representation that, as you may know, it's representation learning. And representation learning usually is used in not in structured data, such as images, such as text, but why not to use it on tabular data that is commonly used in these types of organizations. And our framework, our proposed framework wants to join these two areas, that is data-oriented privacy-preserving machine learning as well as representation learning. So, how do we use representation learning to generate a latent space representation of our data? And we select a type of neural network that is called autoencoders. It's a cool way to create representation learning, or to use representation learning. And it was our particular structure. So as you may know, there's an encoder phase and there's a decoder phase, and they are both linked with our goal, that is the latent space representation. Here we have like the n vector size is the original data set. The m vector size is our latent space representation size. So we iterate a bit. You can learn that further in our paper, but basically this was our proposed framework with just 4 layers between each other. And once we have the representation, the latent space representation vector, we want to know if this representation keeps the performance of the original model. And why? Because you can have privacy-preserving machine learning, but if it doesn't stay up to the standards of your performance, then it would not work. So in this way, we create this framework. Basically means that there are two peers. They both do the pre-processing and usual pre-processing phase, that is the outliers, distribution issues, etc. And they both add an additional step before sharing the data, that is the autoencoder. And here, the objective is that each peer can train an autoencoder model, so they can extract the representation, the latent space representation vector, and then share it to join it together with a common ID. For example, your ID or the, I don't know, here in Colombia we have an ID from every user, so that would be a great way to join the data. And then, as you know, the pipeline will continue the same as a machine learning pipeline. So we decided to set up 5 scenarios. The number 0 is the base model, so that's our baseline, and that's what we would like to achieve. The first scenario is a single autoencoder. Here we want to validate that representation learning actually accomplish the baseline. And the second scenario is having 2 autoencoders. That basically is the framework that I showed you before. And for scenario 3 and 4, we want to add a little bit of bias by adding the downstream task, the downstream task that we would like to predict. So this is basically a multitask neural network, but we are not going to be talking so much about it. So this is like in colors how these scenarios would work. The first one is the darker purple, the first scenario is the blue, and the second scenario is the light purple one. We also use 3 data sets because we want to guarantee that this works for many downstream tasks, as well as feature size and number of observations. And this is the first model. As you can see, the purple line is the baseline. You can see that with a representation error lower than 10%, the performance of the model doesn't decrease a lot, and it still accomplishes the organization's objective. Here's for the first data set. Here's for the second data set, that is with means data and is a classification data set. And finally, here we have the third data set that we wanted to test this framework on. As a conclusion, the latent space representations still keeps the performance of the model while having privacy preserving in the data sharing processes, which is really cool. And as conclusions, we propose this scenario. I'm sorry. We hope that changing the feature set to a represented feature set don't decrease drastically the performance of the model, and peers can collaborate between each other while sharing this representation and not the original data set. As future work, we would like to develop an unique autoencoder structure for each dataset, because that could increase the representation learning feature set, and we want to create metric that tell us how well is performing in terms of privacy. Here we assume that when we encode or embed the data is private, but we want to test it with a metric, and of course test this framework with another dataset. So now, would you test this framework? Thank you so much.